Okay, so what we're going to be discussing today is the 1 to the infinity, the 0 to the 0, and the infinity to the 0 case for limits. So just to remind us of where we're at, again, in the section, we are talking about L'Hopital's rule. Actually, that's not on the A. It doesn't matter that much. And remember that if we're in the form 0 over 0 or infinity over infinity, what this L'Hopital's rule states that the limit as x approaches a of f at x over g at x is equal to the limit as x approaches a of f prime at x over g prime at x. And then in class the other day we discussed the 0 times infinity case, and so if we had the 0 times infinity, remember, and if this was like limit as x approaches a of f at x times g at x, we would write it as one of two cases. Limit as x goes to a of f at x divided by 1 over g at x, or the limit as x approaches a of g at x over 1 over f at x. And we did a couple examples of that. Well, the examples we're going to look at today, or the case we're going to look at today again, is the 1 to the infinity, and I always forget all of the other ones. I remember the 1 to infinity, 0 to 0, and infinity to 0 case. So the textbooks usually have kind of a procedure on how to do these, and the reason I don't like that is I don't like to have to memorize a bunch of things, but we're going to just kind of look at an example that's in one of these forms and see if we can kind of just logic our way through how we could figure out the limit. Alright, so let's look at a beginning example here. So we're going to look at the limit as x goes to infinity of the quantity 1 plus 3 over x to the x power. So this is what we're going to look at. So what we have here, if we look at the form, well, as I go to infinity, this is going to go to 0, but this, of course, is just going to go to infinity. So the form would be 1 plus 0 to the infinity power, or 1 to the infinity power. Now you can't say that 1 to the infinity is just 1, because it's not that we're doing 1 raised to a huge power, because, you know, when x is 1, you'd actually have, 4 to the first power. If x is 2, you'd have 1 plus 3 halves to the second power. So you can't just say, oh, it's 1 to the infinity power. It's an unknown form, because these are limits, remember. So I'm going to write down here what I'm trying to find. I'm trying to find y equals the limit as x goes to infinity of 1 plus 3 over x to the x power. Now the next step is the non-obvious step on these problems. And so we're going to look at this non-obvious step here. And the non-obvious step is I'm going to take the natural log of both sides. And without going into the details of why, you can bring that natural log inside the limit. So it looks like we just complicated this thing and made a mess of it. Now remember, what are we trying to find? We want to find y. Because that's what I have here. I want to find what y is, but I took a natural log, and it doesn't seem like this is going to help me at all, but it actually is a lot of help. Because what happens here? Well, remember a property of logarithms here. I'm first going to write the left-hand side down again, natural log of y, limit as x goes to infinity. And remember, property of logarithms is that you can pull this x down in front. Now, let's see what we've done by doing that. What form is this in now? Well, this x still goes to infinity. And then this is going to go to, well, we know 3 over x goes to 0, so this is going to go to the natural log of 1. But that's equal to 0. So wait a minute, that means the form we're in right now is infinity times 0. And at the beginning of this video, we refreshed how we can do this. Now, remember, there's always two choices that we can do. And I'll write both of the choices down and then illustrate which one we're always going to do with this. So I now have to convert this to either an infinity over infinity or 0 over infinity. So we have natural log of y is equal to the limit as x goes to infinity of the natural log of 1 plus 3 over x over x to the minus 1. Or we can have the natural log of y is equal to the limit as x goes to infinity of x over natural log of 1 plus 3 over x to the negative 1 power. This looks ugly to have to do. You will never do it this way. We will always, with these infinity cases, write it like this. Alright, so then let's go ahead. Now, I could write down the form what this is. If I want to write down the form, this form here is 0 over 0. But really what we end up getting here is we just have to apply L'Hopital's rule. Now I'm going to write here natural log of y is equal to the limit as x approaches infinity of the natural log of 1 plus 3x to the minus 1 over x to the minus 1. So then, natural log of y, using L'Hopital's rule now, this would be, I'm going to write it fairly large, 1 over 1 plus 3x to the minus 1 times negative 3x to the negative 2 all over negative x to the negative 2 power. Now let's see what we can simplify here. Well, the negatives cancel out and these x to the minus 2's cancel out. So then what can I do here? I can write this as the natural log of y is equal to the limit as x goes to infinity of 3 over 1 plus, and I'll go ahead and rewrite this as 3 over x. But then we know that this is going to go to the natural log of y. This is going to be 3 over 1 plus 0. But wait a minute, that just says here I've evaluated the limit and I've gotten 3. Now, careful though. We are looking for y, not the natural log of y. So there's really one more step that we have to do, which is a very easy step. You just convert this and you say, well, if natural log of y is equal to 3, then y is equal to e to the 3rd power. So to just summarize what we just did here, the limit as x approaches infinity of 1 plus 3 over x to the x power is equal to e to the third power. Alright, so we're going to look at a couple more videos, a couple more examples and a couple more videos, but I'm going to end this video right here.